August members of the jury and other Scotch distinguished members. On behalf of Bhilai Steel Plant, I am K. Praveen, General Manager, Environment Management Department. I am making the presentation on the water conservation efforts of late we have taken at Bhilai Steel Plant. Before I get into my main presentation, just I would like to give a brief of the presentation outline. That is the overview of Bhilai Steel Plant, our environmental strategies, the water network at Bhilai Steel Plant, and I will be focusing on the water conservation efforts and details of the schemes nominated for this award and other environmental initiatives which are equally important, but the things that are not being covered under this presentation in this award nomination, I briefly touch upon that. So these are our key environmental strategies to become a global player. That is, we are focusing on these things, that is emission reduction, water conservation, recycling and rainwater harvesting, improving our solid and hazardous waste management, enhancing energy efficiency and reducing CO2 emissions, biodiversity and afforestation. We have a goal set and every year we are measuring, and I'm happy to say that there has been consistent improvement over the past few years, and we are very close to achieving the best in the industry. Okay, achieving the global standard, it may take some time, but we will be one of the very best as far as the Indian integrated steel industry is concerned. So this is our product portfolio. Bhilai Steel Plant is known for its long rails. We produce 260 length, single length rails, which are exclusively supplied to the Indian rails. And our other products are given here. I'm not going to touch upon that. But we make the products which are of national importance. These are the monuments and other national important structures of the nation, where Bhilai Steel Plant is providing quality and value-added steels. Sir, even in our space mission also, for making the rocket launchers, ISRO is particularly purchasing the steel from Bhilai Steel Plant. Those plates are rolled at Bhilai Steel Plant only, and some of the structures that where Bhilai Steel Plant steel is used, I am showing here. So coming to the main part of my presentation, so water is the most important input for steel making, because without water we will not be able to do anything. In Bhilai Steel Plant, water is used for cooling, quenching, dust collection, scale breaking, steam raising, lubrication, and firefighting. These are all operations where the water is used. We have the different reservoirs from where we are collecting the water. That is, our plant is located in Chhattisgarh. So there are different reservoirs from where we are collecting the water. This is the picture of the reservoirs that are spread across the state from where we are collecting the water.
Mr. Praveen, your slides are not moving. Your only first slide is.
Okay, I'm sorry, sir. I don't know how it is. Okay, I will just switch off and I will again reconnect.
Yes, now it is coming. Please go ahead.
Okay, I will show in this mode only, sir.
Okay.
Okay. So in fact, I was talking about. Now you can see, sir, the slides are moving.
Yes, these are now moving.
Okay, okay. So this is the network of reservoirs that you see from where we are collecting the water for our plant operations. These are some of the important reservoirs from where we are collecting, and their capacities are given. That is Tandula, Gondli, Karkara. They come under Tandula River Complex. And another river complex is Mahanadi Reservoir Project. The main project here is Ravishankar Sagar Project, Moramsalli Project, and Dudua Project. So this is our cooling ponds. We have two cooling ponds. That is, one is Maroda 2, which has a capacity of 30.6 million meter cube, and another is Maroda 1, which has a capacity of 9 million meter cube. The Maroda 2 is the freshwater reservoir, and Maroda 1 we call it as cooling pond 1 or the recycling pond. Basically, all the water that is used in the plant is recycled back to this Maroda 1. And this water is again used for our plant operation. So basically our efforts is to conserve the water by recycling whatever water that is generated in the plant to Maroda 1, from where it is being used for industrial operations. Maroda 2 water is basically used for only as a makeup water for Maroda 1 and as a drinking water for plant and township. We have a very big township, sir, which more than 2 lakh population, where not only the employees live, but also the other shopkeepers and so many people from Chhattisgarh, they are living in a township. So we are catering to the needs of both our employees as well as needs of the citizens who are living in our township. Okay, sir, if you look at it, you can see there is a vast difference between the cost of the water, and it is very obvious. When it comes to the government is providing drinking water at a lower cost, but if it comes to the industrial water, it is very costly. That is 12.25 rupees per meter cube. So it is very important for us to conserve this water, particularly the industrial water. So we have taken over the years lot of measures. So I am coming to the main part where in the year 2021 we have implemented some measures. When you look at types of waters in industry, these are the types of different water, that is drinking water, industrial water, raw water, soft water, demineralized water, and deaerated water. The intent of water conservation effort of Bhilai Steel Plant is to save the precious resource water, to bring down our water consumption to achieve global standards. For this, these are the schemes which are implemented, sir. That is treatment and recycling of effluent from plant outlet A, that is 6,000 meter cube per hour. This is the scheme which was implemented earlier, that is in the 2010s. But in the year 2021, we have implemented these two schemes, that is treatment and recycling of effluent from plant outlet C, that is 2,500 meter cube per hour, and treatment and recycling of effluent from plant outlet B, which is 400 meter cube per hour. And there are certain local treatment and recycling systems which have been implemented in our MODEX units. That is, Bhilai Steel Plant has recently undergone for expansion from 4 million ton to 7 million ton. All the new units that have come up have a local recycling systems, so that we are trying to minimize the evaporation losses. The case studies presented in this award are treatment and recycling of water from outlet C and treatment and recycling of water from outlet B to a tune of 2,900 meter cube per hour. So this is our stormwater network. You can see there are different channels which are leading to the plant outlets. We have three main outlets, outlet A, outlet B, and another is outlet C, which you can see here. So there are different channels. Basically, these are all the stormwater channels which are leading to these outlets. These outlets are ultimately meeting the river. So you might be wondering how, when you are recycling all the water, then how this water is finding its way into outlet A, outlet B, and outlet C. In fact, it should have been automatically zero discharge company, but it is not the case, sir. Our plant was set up in the year 1950s. So many of our underground networks have gone wrong. So there are leakages. So once the water leaks, they find their water into the stormwater outlets. So it becomes very important for us to collect the water at some point in the stormwater outlet and again treat it and recycle back to Maroda 1, which you can see here. This is the Maroda 1. This is the recycling part. So if we can recycle this water back to Maroda 1, so obviously Maroda 1 is used as an industrial makeup water reservoir. So we can bring down our makeup water consumption or specific water consumption. So this is our main aim, sir. This is what we have implemented. This is outlet C, which is catering to 2,900 meter cube per hour of water. Sorry, 2,500 meter cube. These are the different facilities that are there in it. That is, we have two pump houses from where the water is lifted and sent to the central aeration tank, from where the water is settled, and then the sludge is separated, the sludge is dried in the sludge drying beds, and then it goes to the clarifiers, from there to the treated water pump house, and from the treated water pump house, it is going to Maroda 1. So this is how the water from outlet C is collected and treated and sent to Maroda 1. By implementing this scheme, this year we are saving about 2,500 meter cube per hour of water. So you can imagine, sir, how much savings are there. Each meter cube costs us 12 rupees. So I will show you. So implementing these two schemes, we are able to save about 30 crores of rupees every year. So, sir, this is the the same scheme where you can see in an animated way. In fact, it is not being shown in a slide form, so I could not show in animation form. So you can see the different facilities that are installed at outlet C, which are being used for treatment of this water and recycling back to this one. So these are the photographs of our treatment plant of outlet C. This is the flash mixture where the suspended solids are separated. Then these are the clarifiers. We have two sets of clarifiers. And from there, the clarifiers, all the dirt is get settled. From there, it is again collected in a treated water tank, and from where it is recycled. The similar facility is also implemented for outlet B. There we have one oil removal tank because outlet B contains little bit of oil. So we remove the oil from there and we reduce we adjust the pH. Then we take it to the treated water sump, and from there it is again sent back to Maroda. So these are the two schemes that we have implemented, sir. These are some of the photographs which of the outlet B. So you can see over the year how our specific water consumption has come down. In fact, sir, in early 90s, our specific water consumption per ton of crude steel was about 20 meter cube per ton of crude steel, which was very, very high. Now you can see over the last 10 years, we have come down from 3 to 2.76. It might be looking very little, but you must understand that Bhilai steel plant has gone from 4 million ton to 7 million ton last year. In spite of increasing expanding, our water consumption has not gone up. So it remained same. So that is one object. So this is the most important. What are the challenges and innovation that we have implemented in this project? The challenge is effluents of different characteristics are coming from different channels. Mixing of the streams in right proportion to reduce so that it becomes a self-treatment process before it is sent to thereby reducing the treatment cost. This is the innovation that we have done. If some channels are having high pH, some channels are having acidic pH, we have mixed it in such a proportion that the treatment takes place automatically. For that, we have to do a lot of engineering, and we have successfully done this. So that is how the overall treatment costs have come down. Identification of huge chunk of land, about 50 to 75 meters area for setting up of the facility. Bhilai steel plant is very, very congested. So already most of the facilities have come up. So to set up this much area, identify this area has been a challenge for us. So what we have done is there is a marshy land inside the plant which is of no use. So we have selected that land, we have developed it, and we have placed our treatment plant there. So the precious area which is left behind, we can use it for further expansion. Then the next problem that we faced was diversion of the effluent to the central treatment unit. Earlier, the engineer has suggested, the consultant had suggested that we have to set up a sump somewhere and you have to pump the water to the treatment plant. So, but our own engineers have interfered in that. Then what they have done is they have selected the sump at a place so that the water from the sump to the treatment plant can be diverted through gravity. So all the pumping costs have been avoided. So 80% of the total effluent, that is 2,900 into 0.8, about 2,500 meter cube per hour of water is being diverted to the plant, central plant through gravity. That is how we are able to reduce the pumping cost. Generation of huge quantity of sludge. It is about 50 ton per day. So what we have done is most of the sludge is inert, non-toxic and ferrous sludge. It is being used for filling of the low-lying areas and other construction purpose. In future, we have the option of recycling in the manufacturing process of iron as an iron-bearing material because it has a Fe content of 36%. So we are doing the testing process. Once this process has been established, so we mix it with our iron ore fines, and that way we will be able to recycle it.
Sorry, sir, for interruption. Can you please conclude your presentation in 2 minutes?
Sir, I will. Just this will be my last slide. These are the benefits that have been achieved, sir. Our environmental concern, that is discharge of water from the plant, has been addressed. That is specific water consumption has been maintained at 2.76 meter cube per ton of crude steel in spite of expanding from 4 million ton to 7 million ton, meeting the process water requirement to 7 to 10 million ton. We have sufficient water even if we go to 10 million ton per annum. We have sufficient water to meet our requirements. Potential savings of 31 crores every year. BSP has also expressed interest to cater to the needs of the farmers. We are also interested in meeting the needs of the farmers. If there is demand from the farmers from the adjacent areas, Bhilai Steel Plant has expressed its willingness to supply this fresh water for their agricultural purposes. BSP is also written to NSPCL, that is NTPC and a joint venture of NTPC and SAIL, to draw the treated water for the recycling plant. Right now, they are taking raw water. So if they take the treated water, their treatment cost will come down. And also to meet the cooling water demand. We have also written to the Chhattisgarh Environment Conservation Board member secretary, asking him and offering our water for the utilization by the other industries. So that way we want to help the other industries also in meeting their water requirement. Okay, sir, this I would like to finish my presentation. Thank you.
Mr. Praveen, very commendable job. In fact, you have done. I would like to little bit know about your this sludge of 50 tons per day,
Right,
which you state that it has 36% Fe content.
Right, sir.
So by when you want to you propose to utilize this Fe content to recycle so that you can extract iron from
Sir,
it?
actually, what in our sinter plants we require an Fe content of 55%. So what is happening is, because our iron ore fines has also over the years their silica content has increased. Okay, actually we require in iron ore fines we require a Fe content of more than 60%, minimum 58%. So this we need to do the blending in such a way that that is only little percent of the sludge is utilized in the iron ore fine. So our RCL, that is our research and control laboratory, is working on that process. Most likely within a year or two, we are in a position to utilize it back in our processes. Or otherwise, what we are going to do is, there are so many sponge iron units are there. We are already in touch with them. For them, it is not an issue. Even low Fe content also they will take. They will separate out the silica content. They use it for making direct iron. That is pig iron they will make. So we are in touch with them. So that is what we are proposing to do.
Okay, thank you very much.
Thank you, sir. Thank you for your nice words, sir.
Sir, in your presentation, you have stated that your water consumption has come down from 2.99 to 2.76
Right, sir.
per TCS. So I would like to know what is the international standards.
Sir, international standard is, even I am happy to say that it is the Vizag steel plant, which has achieved 2.35 meter cube per ton of crude steel. Sir, when you say that international standard, you have to compare like to like cases. So the plant which has the similar operation, so Vizag steel plant has able to achieve in the year 2010-11 a specific water consumption of 2.35 meter cube per ton of crude steel. But now their water consumption has little bit increased. I think now they are operating at about 2.5 meter cube per ton of crude steel. So we are at 2.76. So we have some more plans, sir. Actually, I have its slides, but the time is a constraint, so I'm not showing. So what we are going to do is, in future we have already implemented a number of water recharge units, that is rainwater conservation plants. So we want to go for more and more rainwater conservation. So we bring down our process water requirement that way. So we also want to reach a target of 2.4 within next 2 to 3 years.
Good enough. Excellent project. Thank you.
Thank you, sir. Thank you very much.
Good.